these are all the main parent functions that we are being held accountable for. So our goal here is be able to see these graphs and be able to identify what equation matches it. And vice versa, if we're given the equation, we're able to match which graph goes with it, or be able to draw a generalized graph to it. So let's just go in order on these, and I'll talk about any details that might be helpful along the way. Our first one is, and they're always y equals something. It's in terms of the output, the input in terms of the output. So this is just y equals x. It goes straight through that diagonal. We're in quadrants 1 and quadrant 3 here. It's a flat line. So I kind of like to think about how many bumps it has. It's always one less than what this exponent is. Since that's exponent 1, one less than 1 is 0. So notice this line has 0 bumps in it. Our next graph here, this is y equals x squared. Notice it has that one bump idea. And it's going to infinity in the positive directions. Also, I can plug in any number I want into x or any negative x. So it's real important to kind of know, is there asymptotes or is it blocked on the sides? No, it goes off forever. It goes forever up and forever left and right. Our next one is y cubed. For this, y equals x cubed. This one has at most 2 bumps. It's hard to see it here, but it can have 2 bumps on it. So it can look like that, or it could actually go the other direction and look like that. But for this one, they're just using the simplified version of it. And notice they do go on forever. I can plug any x I want in, any negative x I want in, and we got positive and negative y going in each direction. The next one is y equals the absolute value of x. This one has a very distinct corner kind of idea here. It switches over in that corner for when it goes from positive to negative as our inputs. So it's just like y equals x and y equals negative x on the top. Nothing there, and it's a common problem where they try to trick you, and negative y's are not in the range, so it's not possible to have a negative y here. The next one, this is our y equals the square root of x. The square root of x kind of grows real slowly, goes on forever. This one right here is y equals the cube root of x. The cube root goes in that crux of the root or radical sign. Goes on forever. Even though it doesn't look like it, it does go up and down forever too. This one right here is y equals 1 over x. It has the asymptotes on the x and y axis. This one right here is our exponential. So that would be y equals, and they're just saying a to the x. It looks like I'm missing one right here. So the one that I'm missing, I'll go ahead and include it. We can have a graph that looks like this also. So that would be if x is squared on the bottom. That's 1 over x squared is for our y. We had the exponentials. This one, the key is, where does it hit the y-axis? This hits the y-axis at 0. That's your sine function. That's y equals sine of x. This one hits the y-axis at 1 in general. So that's our cosine. Y equals cosine of x. And our last one is log of x. So this would be y equals log, I think they use base a of x. It's really important to kind of recognize that these are inverse functions. If you imagine the y equals x line, it's reflected over it for these. So these two are very distinctly related. Very important that we start to practice these and get used to them, write them down so you can kind of reference them when needed. All right, so I wanted to introduce you with some of the key aspects of dealing with parent functions. So for our first one, hopefully you can kind of recognize what's going on here. Basically, you don't want to let all the extra letters kind of throw you. We're looking at the y and then what's happening to the x. So the y is already by itself. What's happening to the x is basically it's getting squared. So this is like y equals x squared, okay? That's going to be our base function. And what this means is a kind of, in this case, it's a parabola. So a affects how steep or how not so steep the parabola is. And it can also flip it. So the a we're not going to worry about too much. But the h, notice the negative sign in this parenthesis right here. So you always have to have the grouping symbol. That's one of the characteristics of it. And that negative means it's an opposite action on whatever that number is. So whatever this number is, this moves on the x-axis, A-X-I-S. It moves on the x-axis the opposite way. Opposite way. So it moves on the x-axis in the opposite way. So whenever I see this, I always think whatever that number is, it's moving it in the opposite direction of what that number is. Okay? And then the last one is the k. That last k, or it's a number all by itself, separate from the parentheses. And that moves on the y-axis. So when I say x-axis, I'm saying left and right. When I say y-axis, I'm saying up and down, depending on what that number is. And it goes in that same way. We got a plus sign there, so that just tells you how far it moves up and down. Okay? Let me just go ahead and maybe do a generalized parabola here. So this would be our normal parabola of x squared. And then let's say I moved it down k units, and I moved it to the right h units. Okay? So if I were to write this out, that would be y equals the a. We're not really sure about what adjustments that's happening there. The h did go in the positive direction, so that'd be x minus the h squared. And in this case, the k went down, so that would be a minus k on that one. So I usually start with kind of the vertex or the bottom of it, and it would look just like the other one, but in this case, it moved down by k, and to the right h units. Whatever that number is, the opposite, so I always look at that as like a negative h, so the opposite of that is positive h units. All right, so let's actually try to do some of these now. I like starting out with the parent function. So the parent function here, hopefully you can identify, is y equals the cube root of x. So that would look something like that for the cube root of x. And then, do you remember what I said about that plus 3? What action's going to happen there? Whatever's happening exactly to x inside what would be kind of like the parentheses here, or that grouping symbol of the radical, is an opposite of whatever that number is. So this is basically moving, and for this one, I'm kind of focusing on where that shift is kind of going on at, the origin. So this shift would move 3 units in which direction? In the negative direction, 2, 3. That's a positive 3, so it goes to the negative 3 on that one. So this now becomes 1 to negative 3 there. That's my kind of inflection point. Don't want to shift up at all. Goes like that and goes like that. That's all there is to it, is we just move it in the opposite direction on that one for the x, and then if there are anything else out here, that would be a direct up and down movement on the y. All right, that's what we have in this last one. So do you remember what I said to start out with? We start out with the parent function. What's happening to x here basically? Well, basically here this is a y equals x cubed equation. X cubed kind of has that action going there for the parent function. And then what's the effect here? Do you remember? Well, it's exactly the same as that one. It links together. And then what did I say was the effect for that one? Okay. So in this case, and notice this kind of links directly with this one that I kind of did. So I'll just go ahead and this is the point that I'm kind of looking at. I think it's called like an inflection point. It's where things kind of change a little bit. And it's going to go to the left 3, 1, 2, to negative 3, and then this one goes down, 1, 2, 3, down 4. So I'll go ahead and just draw a new graph. So this graph turns into 1, 2, negative 3, 1, 2, 3, negative 4. There's that inflection point. So it's going to have that action of going down and coming up. So it goes like that. And yes, everything looks good.